Welcome again to the continuation of the topic one-way ANOVA. Want to see how to solve the question we have on the board. Before you solve this question, you must have what we call ANOVA table or F table. You must have F table, that is a 4-figure table, because you have to take readings from it while concluding your results. Now, this is a typical example of our F table. I'm holding my own now to solve this. Now, look at this question. We noted that in one-way ANOVA, it has a table which is sketched this way, where the first one is source of variation. Between treatment, we have K minus 1. Within treatment, we have M minus K. Then total, we have N minus 1. We sketched this in the previous video. So, here degree of freedom, here sum of squares. Sum of squares for treatment, sum of squares for error. Then sum of squares for total. Then we say the next one will be mean of squares, where you say SS treatment all over K minus 1, SS error all over M minus K. Then we have our F ratio, which we say is gotten from Fishner, a man called Fishner. F ratio is MS treatment all over MS error. Then we said there are important formulas we need here, and that is one, SS total equals to SS treatment plus SS error. Then the next one is that we have that SS total equal to summation of y square ij minus y squared all over n. Then SS treatment equal to summation of yi squared all over n minus y squared all over n. Then SS error is equals to summation of yi j squared minus summation of yi squared all over n. These are formulas we need in this. Once you finish computing this, you have to say, let me conclude by saying F calculated, are you greater than F table? This is gotten from table, this is gotten from our calculation. If this is greater than this, you say reject null hypothesis. But if this one is not greater than this, if this is less than this, you say accept null hypothesis. So we need to have this in our mind as we go into this question. The question says, live traps are set to capture samples of rabbits at different locations in a large wooded area. The weights in ounces are given in table below. That's the significant difference of the mean weights in the areas at 5% level of significance. Then they say take the null hypothesis to be mean weight of the rabbit in 5 areas did not differ significantly. Then this is alternative hypothesis, mean weights of the rabbits in 5 areas differ significantly. And they gave us table of values or readings. Now when you are given this, say that name here to be your K. Name here to be your K. K means we have 5, 1, 2, 3, 4. We have 5 data here. Then say that here is your NI. And what is the first value of NI? First value of NI will be 3. Then the next value 1, 2, 3, 4. The next value 1, 2. The next value 1, 2, 3, 4, 5. The next value 3. Then after that, get your y total, yi total. How do you get your yi total? Use your calculator. 37 plus 40. 37 plus 40 plus 46. That will be giving us 123. We have 123. Then the next one, we write 29 plus 33 plus 34 plus 31. We'll be having 127. Then the next one will be 96. The next one 40 plus 38 plus 42 plus 39 plus 41. We'll be having 200. Then we now say 50 plus 46 plus 49. That will be giving us 145. So we have gotten our total. We have gotten total for y, for this 37, 40, 46 and others. So having gotten this, we now say, okay, what is the total n we have? Total n means add everything. 3 plus 4, that will be giving you 7 plus this. That will be giving you 9. 9 plus this, 14 plus this, 17. Say that this is. So, from this information, we say that this is the individual values of n. First n is 3, second n is 4, third n is 2, fourth n is 5, and fifth n is 3. These are individual values of n. Okay? Then, for your k, you say that k is equal to how many? 1, 2, 3, 4, 5. You say 5. So you have gotten your k to be 5. Now, what do we do? Remember that capital N means total values of this n we have. Total values of it is 17. Now, how do we now do now? We now say, okay, let me get my SS total because I need it in my table. I say SS total will be equal to summation of yij simply mean squared. Simply mean I'm to square everything. So I will start squaring everything. I will say SS total equals to 37 squared plus 40 squared plus 46 squared plus 29 squared plus 33 squared plus 34 squared plus 31 squared plus 49 squared plus 47 squared plus 40 squared plus 38 squared plus 42 squared plus 39 squared plus 41 squared plus 50 squared plus 46 squared plus 49 squared. So once you square everything, every data you have here, once you square everything, you say minus y squared means I have to add up everything here. If I add them up, it will be giving me 691. I'll say summation of yi equal to 691. That is 123 plus 127 plus 96 plus 200 plus 145. 691. Then 691 will be giving me 691 squared all over. Capital N means 17. This implies that once you compute this with your calculator, if you compute it with your calculator, you'll be getting 28,769. 28,000. If you compute everything here with your calculator, you get 28,769. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 17. Once you compute all of them, it gives you this. Then minus 691 squared all over 17. If you compute it, it will be giving you 28087.12 approximately. So once you subtract these two, that will be giving you 681.88 when you subtract it. That is your SS total. Okay? Now you say SS treatment will be equal to, the formula says that SS treatment equals to summation of yi squared. Okay? That means yi, this is for yi. I will now say 123 squared. They say square it all over. What is the n of it? 3. Plus the second one, 127 squared all over the next one over 4. Then the next one, 96 squared all over 2. Plus the next one, 200 squared all over 5. Plus the next one, 145 squared all over 3. Then once you compute it finish, you now say minus 691. That is y squared. Y means everything. Y means add up this, you get 691 squared all over 17 because capital N is 17. So y, summation of y, everything y is 691. That is why we write 691 as formula says squared all over 17. Then if you compute this, this will be giving you 28691.583 minus 28691.583 minus 2. This one will give you 28087.12 as you got here. Then when you subtract the 2, you will be having 604.46. That is our SS treatment. Then from the formula we have, I can clean the question. From what we have that SS total equals to 681.88. SS treatment equals to 604.46. Now, since SS total equals to SS treatment plus SS error, it means that SS error will be equal to subtract these two. And when you subtract the two, this minus this, that will be giving you 77.42. 681.88 minus 604.46. That will be giving you 77.42. Okay? So that is for this. We have gotten an SS total, SS error, and SS treatment. We come to our table. K means 5. 5 minus 1, we say 4. N means 17, K means 4. N means 17, K means 5. So, capital N 17 minus 5, that will be giving us 12. And capital N means 17. 17 minus 1, 16. Then, what did we get as our SS total? SS total is 681.88. SS error is 77.42. The SS treatment is 604.46. Okay? Now, for you to get MS treatment, you say SS treatment minus divided by 4, which is K minus 1. This divided by this, what will it give us? It will be giving us, if you divide, it will be giving us 151.1 approximately. Then this divided by this, it will be giving us 6.46 approximately. Now, MS treatment over MS error means this divided by this, we'll be having it to be 151.1 all over 6.46. And that will be giving us, if you check the two, it will be giving you like 23.39. So this over this is this. This is taken to be calculated F value. F calculated is what we have here. F alpha. Let's get our alpha. Now the question says at 5% level of significance. Alpha 5%. 5% means 0.05. So if you want to check this from your four figure table, see what you do. This F that we are getting from our four figure table, F alpha, is what is between treatment, that is K minus 1. That is what is within treatment, that is N minus K. So we will check this F alpha under this, where the first one will be the numerator and the next one will be the denominator. So what we do is that, what is K minus 1? 4. What is N minus K? 12. You go to your F table. When you go to your F table, you will see where they write numerator and denominator. Numerator will be the first one, that is between treatment, K minus 1, that is 4. And denominator will be the one within treatment, that is N minus K, 12. So we now say, okay, taking 4 as the numerator against denominator 12 under 0.05. Under 0.05 via 0.05, which is your alpha. You go to 0.05, 0.05, under 0.05, you have 4 and under 12. That will be giving us 3.26. So we say that our F alpha will be 3.26 from our table. From table. Taking it under 0.05 from your F table, under numerator 4 and denominator 12. Numerator 4 and denominator 12, it will be giving you 3.26 from table. Now, having known this, you now conclude. You have to make a conclusion now. Conclusion says, if your F calculated is greater than this, reject null hypothesis. Now, what is our F calculated? Our F calculated from our table is 23. If F calculated is greater than F table, that is the one of taking it as alpha via K minus 1 and N minus K. And that your alpha is 0.05. Because they say 5% level of significance. So what you now do, what is F calculated? You say 23.39. Are you greater than, what is F table? F table is 3.26. Since this is greater than this, it means reject null hypothesis. Reject null hypothesis. So the implication is that, what is our null hypothesis? It's a mean weight or rabbit defined area did not differ significant. So rejecting it means we have to accept the alternative. So our conclusion will be that From this experiment or from this interpretation, we realize that finally we conclude that mean weight, we just write this, mean weight of the rabbit in 5 areas differs significantly. Differs significantly. But if this is not greater than the F tab, if the F tab is not greater than F tab, you say that I will accept. If this is not greater than the F tab, I will say that I will accept the null hypothesis. That is saying that mean weight in 5 area did not differ significantly. But because the F tab is greater than F tab, we now say we take the alternative hypothesis and reject null hypothesis. Then taking the alternative hypothesis means we say mean weight of the rabbit in 5 area differs significantly. Full stop. That is how to solve one-way ANOVA. Now, we want to go into two-way ANOVA, see what we can learn from it. See you in the next video. Please and please don't forget to subscribe to my YouTube channel. Just click subscribe. It will not take your money. It won't take your megabyte. Then click like button as you enjoy this topic. See you in the next video.